Now we know how to test whether a given ordered pair is a solution to a system of equations. But the next question is, how do we actually find that solution? We're going to look at doing this graphically. As a reminder, you've likely seen in some other courses that there are other methods for solving systems of equations, including substitution and elimination. Those are algebra-based methods where what we do is manipulate the expressions, get rid of a variable so that we can solve an equation in one variable, plug that back in to solve for the other. If you're familiar with substitution and elimination and you want to use those methods, please feel free. But our emphasis is going to be on finding these solutions graphically, as that will tie in more to the later topics that we're going to cover. In order to find a solution graphically, what we need to do is plot each line. In this case, we'll pull on the equations that we had in example 1. We can plot y equals 1/5 x plus 6 by plotting a y-intercept at y equals 6, and then moving up 1 and over 5 to get to our next point. Then we can graph that second equation, y equals -3/5 x plus 10. We'll start with that y-intercept of 10 and use our slope to move down 3 and over 5. In this case, that pair works out really nicely. We plotted that point at exactly 5, 7. Wherever our two lines intersect, that point of intersection, that xy pair, is the solution to our system of equations. As long as we draw our graph accurately, we can pick up our solution that way. But instead of graphing these by hand, we're going to rely on technology to graph these equations and help us find those solutions. So in examples 3 and 4, we'll flip back over to Desmos. And we'll start off in equation 3 by graphing y equals 1/2 x plus 2 and y equals 5/2 x minus 2. Desmos does a lot of handy things for us. For instance, I can already see these gray dots popping up. Those are giving us sort of particular points of interest. Here it's showing us an x-intercept. If we clicked on the purple line, it would show us the y-intercept there. And if we click right where those 2 points intersect, it's going to give us that xy pair. So in this case, our solution to that first system would be 2, 3. So those two equations intersect when x is equal to 2 and y is equal to 3. Similarly, we can find the solution to the system in example 4 by graphing y equals 4x minus 1 and y equals -3x minus 8. So we see that little gray dot and we find that point of intersection at -1, -5. The other thing to be aware of when we graph these solutions is that your point of intersection may not show up initially. There are tools that you can use on a graphing calculator or in Desmos to manipulate the viewing screen, the viewing window. In this case, there's just a simple plus and minus button you can use to zoom in and out. And then there are also some tools to set specific limits for your x axis and y axis. In some later examples, we'll take a look at how to use those when our initial solution isn't immediately obvious to us.